Hey guys, welcome back. Today, we're going to be talking about perspective. So, today's session is actually divided up into two portions. The first is going to be a lecture on perspective, and then the second is going to be a demonstration taking our newly found knowledge and applying it to some studies, and further developing our understanding of perspective. Perspective is one of those elements of your foundation that you really don't want to skip on. And the reason why is because what we're about to learn today, it's science, it's math. This is the way that we see the world around us. And if you have failed perspective in your drawings, even non-artists are going to be able to tell that something looks off. It doesn't look right. They may not be able to tell you what looks wrong, but they'll be able to say that it doesn't look real to them. So, what is perspective? Perspective is the way that we see the world around us. It is the human's eye ability to have an understanding of three-dimensional form. And throughout the years, artists have been able to take the visual aspects of the physics of how we see this and apply some science to it, as well as some really easy methods to follow and build out perspective grids in order to properly communicate our ideas on paper and represent them like we see them in real life. And this is one of those elements of your foundation that, if you think of this as, let's say you're learning a new language, let's say you're learning English, and there's the alphabet, A through Z. You can think of perspective as some of the letters. We'll just say B, C, D. And let's pretend if you have to write a paper. The comparison is you're making an artwork. If you have to write a paper and you don't have the ability to use B, C, and D, then you're going to be very limited by what you can produce. You may try to substitute it, you may try to overcome this limitation by using other methods such as creating everything as a flat design drawing or using 3D to get away from having to learn perspective. But sure, you can do it, but you're not going to have a solid foundation, and eventually this is going to bite you in the ass. So that's why I find it very important to learn this, learn the basics, and once you've mastered it, you no longer have to even think about it. You're going to be able to just paint and draw and understand what is going on in your scene perspective-wise without having to start including a vanishing point, a horizon line, all these elements that we're about to learn in today's lecture. So let's go ahead and let's look at some examples. So what is perspective? So this right here is a perspective grid. This is a 2-point perspective grid, and we're going to learn that very shortly. But having this grid gave me the ability to create this drawing. So you could see that one is the visual space, and then this is the drawing inside of that visual space. So this is them overlaid on one another. And like I discussed earlier, we can go ahead and create flat drawings. We don't have to necessarily design in perspective all the time. But having that understanding as a concept artist, as a production artist, is going to further give you the ability to communicate with your team. So let's see why that's important now. So here's an example of this right here. There's no perspective in this drawing, this painting. It is purely a flat, two-dimensional drawing. Same with these little facades right here, these architecture explorations. But now when we take perspective, we can apply it to a 3-quarter drawing, and we can give this to a modeler, and a modeler can go ahead and now visualize our building without having to, with having a clear understanding of what it is they need to create. So this is why, yes, it's important to have a good design ability, but it's also very important to have good drawing ability so we can communicate our designs. And perspective is one of those abilities that is going to allow us to communicate these spaces. And it's not just for environments. Everything that we see with our eyes has perspective. Props, characters, vehicles, all of that has perspectives. So let's go ahead now and learn a little bit about perspective. We're going to start with having an understanding of the basic shapes. So right here we have our three basic shapes. We have a rectangle, a cube, a circle, and a pyramid. These are all 2D. They're flat. They have no form to them. What happens is we begin to give them form, and we can see them in perspective now. We have a cube. We have not a triangle, but a pyramid, a cylinder, a cone, and a sphere. These are the 5 basic shapes that, if you can master these, you can really draw anything that you want to. Because after you can combine all these different basic geometry forms together, the rest is adding details. It's modifying them. So let's focus on mastering these and be able to communicate our drawings. So before we begin with learning about 1-point perspective and 2-point perspective, let's have an understanding of some of the terms that we're going to use. The first is the horizon line. The horizon line is simply where the sky meets the ground, or in this case, the ocean. It is as far as your eye could see where those two converge. And one thing too that I wanted to mention is that I'm going to be using a lot of slides that I created from a perspective video back in 2012. What's cool about this is that, you know, in the past years, the knowledge of perspective hasn't changed. And before that, the knowledge of perspective, well, not the knowledge, but perspective itself hasn't changed. As humans, we've now developed a way to have an understanding of this, and let's project 100 years into the future, we could still use these slides here because, once again, the science of this is all the same, and it's timeless. That's why once you learn it once and that's it. It's not gonna change in the future. At least it shouldn't be. Maybe if our eyes start, you know, mutating, but let's hope for that not to happen. So going back now here to the lecture. So the horizon line. This is a point in space that is eye level, where the sky meets the ground. Okay, up next we have a vanishing point. A vanishing point is going to be where your lines converge. So if we look at this as a top-down drawing, it is a rectangle, just a simple rectangle. When we put it in perspective, these lines now begin to converge to this vanishing point. Same with these. And you can have multiple vanishing points. So this is one vanishing point. This is 2 vanishing points on the horizon line. Okay, what other terms do we need to be familiar with? There is the station point. The station point is where you are in this scene. So this is you, this is your, this is a top-down view right now. So this is either your eyeball or this is where your camera is. And then as we project it out, we can start building up our horizon line. So talking about the horizon line, it has certain characteristics that we can use in our advantage drawing. One of that is that the horizon line has a height. And unfortunately, this isn't actually taught very often, but it's very important because let's say you want to draw something on this horizon line. And let's say we draw this box. And this right here is a ground plane. And this is the horizon line. On this ground plane right here, anything that sits on it has a height of 3 feet once it gets to this horizon line. If it goes taller, then it's taller than 3 feet. If it's lower than the horizon line, then it's smaller than 3 feet. But if it lands right there, it's exactly 3 feet. So here's another rectangular box on the ground plane, but it's only 3 feet tall. Then here's one more in front of that. They all have the same height. So why is this important? So this is important because if we're drawing a scene and you go ahead and lay out your horizon line, if you put a figure on it and that the figure is, let's say, 6 feet tall, let's say the figure occupies this space, if you could follow my mouse. That means that if his torso or his waistline is around right here, that means it's 3 feet off the ground. So if we draw a figure back in space, we now have the ability to know that right here is 3 feet and we can draw his waistline there. Same if he's standing really close to the camera. Really big. Right here is going to be 3 feet. And we'll get to some more practical examples of that in the future. So those are our basic terms. Let's cover them again. We have the horizon line, vanishing point, which there can be multiple of, our station point, which is where we are or the camera is, and then this is just talking about the horizon line again. So now let's talk about one-point perspective. What is one-point perspective and how do we use it? So here's a top-down view. Pretend we're on the ceiling looking directly down, and this is going to be a profile view, a side view. This is our three-dimensional scene. So here we draw out converging lines. These lines, like we discussed earlier, they're parallel. If we go a few slides back, that's these two lines. They are parallel to each other. And they converge to this vanishing point. So now let's draw on the ground plane. We're going to draw a box. So this is that box drawn on the ground plane. Let's now project this upwards. For one-point perspective, our vertical lines are going to be perfectly 90 degrees, so up and down. The same goes with our horizontal lines, 90 degrees. There is no convergence. This one, if they're taking place on the ground plane or going backwards in depth, they converge. Otherwise, they're 90 degrees left and right, up and down. So there's the top, the front of it. There's the lines going backwards. And then we complete the shape. So we drew this box by drawing where we wanted to sit on the ground plane, drawing it flat on the ground, projecting it up, backwards, and then connecting the rest of the lines. So we go back to the vanishing point, we go up from these back points, and then connect these dots. And now you can see why it's very important to have the ability to draw two connecting points. Because right now, we're using shift-click in Photoshop. But when we're drawing, we want the ability to freehand sketch this back, connect these 2 points, and connect those 2 points. Alright, so here's one box. Remove the grid, that's what we're left with. We have the draw-through lines, they're ghosted in, and now we just have a clean box. Let's do it again. Draw on the ground plane. This time we'll draw the front view first. So before we drew the bottom, this time we drew the front. And then it's going back into perspective. We draw that line for how long we want it. Carry these lines over, connecting the dots. And now we have another box. And you can do this on and on. So now we have boxes behind, boxes in front. We complete them and erase away what's beneath it. And we could do that again. So that right here is one-point perspective. Now let's talk about two-point perspective. Two-point perspective it has the same principles as one point, but now instead of looking directly at the box, we're going to put it at an angle. We walked off to the side and we can now see, we can see these lines converging left and right. So if we take this image right here, we can find the horizon line. The horizon line is drawn where things are flat. So this line isn't flat, that line's not flat, but as we start going in between them, we can see right around here, all the lines of these buildings is pretty flat. So we're able to establish our horizon line. And just like we mentioned before, from the ground plane, the horizon line has a height. So if we estimate that this person right here is 5.5 feet tall, we can duplicate that by just going upwards. So 1, 2, 3, 4, all the way up. And then we can estimate now that the horizon line is 50 feet tall. That means that we, as a camera, are established 50 feet above this ground. So we're most likely on the roof of a building. So why is that important? Well, that's important because if we're doing a drawing now, and if we want to establish that we are on top of a building, we want to establish that our horizon line is this tall by drawing downwards scale that makes sense to be 50 feet tall. Okay, so now let's reverse engineer this photo. Let's find where the vanishing points really are. So I made it a little bit small on the screen so we could see it here on the page. The way that we're going to find our vanishing points is by taking these parallel lines and converging back in space. We're just tracing over them. So we'll find that one. We'll find another one, the tops of these windows. And right there, where these 2 points converge, that's a vanishing point. Let's do the same thing going the other way. So we'll take this sidewalk, go backwards, and then maybe the bottom of these windows. The more spread out this gap is, then the more accuracy you will have finding these vanishing points. And then when we connect those two lines, we have the horizon line. So this is our horizon line in blue, and this is our vanishing points in red. Now that we reverse engineer the picture, we can go ahead and create our grid. Let's zoom it in. So we'll just take lines off this point and we'll just draw them out in our grid. It doesn't matter where you stop, the further the better, because that way you can have a better grid to draw with. So right there is our 2-point perspective grid. Okay, let's discuss what else is important with 2-point. So our horizontal lines now are no longer horizontal. They converge to a vanishing point either on the left or on the right. And then our vertical lines, they're still vertical, just like in 1-point perspective. And later, when we become more advanced, we'll start to understand how to use these lines to represent different cameras, different focal lengths. When we use wide angles versus a telephoto, one that really zooms in, it will flatten the scene. And this can become very useful that when you're doing your drawing, what if you're really low to the ground and you want to project on your image that things are really, really tall? What if you're a mouse looking up at a table? Or the opposite, what if you're a bird flying in the sky looking down at the city? We could begin to use these to our advantage of zooming in and out and flattening it with some of these converging lines that we're now going to discuss in 3-point perspective. So we learned 1-point. 1-point has 1 vanishing point. 2-point has 2. And both of them have their vertical lines, the lines going up and down, just perfectly 90 degrees to our picture plane. Now let's talk about 3-point perspective. You may be looking at this image thinking it looks very similar to 2-point perspective. You know, we can find a vanishing point going left and right. There's another one over here somewhere. You know, there's the horizontals aren't perfectly 90 degrees. So, okay, it looks like 2-point perspective. Well, when we take our verticals and we begin to converge those, if those begin to converge, we now have a third vanishing point. So this is only looking at the verticals. They're converging downwards, meaning we're high up. We're probably more than 50 feet tall looking at this image. Here's another one where we're on the ground and we're looking up. These lines are vanishing to the left, so 1 point, and these are converging to the right, 2 point. Well, our third point are these verticals now. So it's probably a 3-point perspective image. And then these two examples, they're going slow. So the convergence is minimal. If you look at the difference in these two lines, they're not parallel, but they're not drastic. Well, if we want to show something really, really tall, we could show that point on the page. So this is up looking all the way up at a tall building, and these lines converge on the page itself. So what does that look like on a grid? It looks like this. Let's first draw on our picture plane. We've established a vanishing point, and we've established our horizon line. So here's a vanishing point. We'll draw our parallel lines converging back to it. We'll draw on our second point way off the page, but they're slowly converging towards that on the horizon line. And if we zoom out, we'll go down from our vanishing point that's on the page. We'll draw on our third point, and then we could do the same by exactly just flipping it upside down. So on this one, point's down. This one, the point is up. And if we remember with this picture example, when we look up at something, that third point is up. So when we look up at something, that third point is up. We're looking up here, we're looking down here. That's what those two examples look like. And then we can continue our box exercise and go ahead and start drawing inside our picture plane. So these are the basics of perspective. These are the essential fundamentals, 1, 2, and 3 point, having an understanding of where those points are, where they lay in space, why they're there, and how we're going to use them for our drawing. Now that we have an understanding of these principles, we could start talking about some more advanced elements of perspective that we use in our day-to-day. And also, this isn't meant to be the most thorough analysis of perspective right now. This is a basic introduction that can get us started. We're going over the principles, some of the ideas, as well as some of the intermediate aspects of it that will allow us to start drawing. But if you really want to master your perspective, what I recommend is, there's the other video I mentioned, Fundamentals of Perspective with Matthew Zickery. There is Scott Robertson's How to Draw book, as well as a very good basic book called, I believe it's called Perspective for Comic Book Artists by David Chelsea. That one doesn't necessarily go through as much of the exact step-by-step, but it's more of a practical understanding of how do we apply this on our day-to-day. But let's go ahead now and talk about a few other elements that I find very important for understanding before we should get drawing. So let's talk about how to repeat elements in perspective. This is important because if we go ahead and draw something and we want to draw that same item further in depth, let's say we're drawing a building and we want to have that same exact building further in the drawing plane, then we need to understand how can we repeat it. You'll see this all the time. There's the common cliche drawing of telephone poles going back in space, railroad tracks, things that they have symmetry to them and they're repeatable when it comes to space. So how do we repeat elements in perspective? All right, here we went ahead and we just drew a cube, a square. and we laid it on the ground. Let's do another visual representation of what it looks like in a top view versus what it looks like in perspective. So here's that. And then I went ahead and I added another square. I keep saying cube. Cube is a 3D form, square is a 2D form. We added another square behind it. But we don't necessarily know where to draw this line. So looking at this in 2D, let's come up with some creative ways to duplicate this just in a flat view. And if we can do that in a flat view, then we can probably come up with a strategy on how to do that in perspective. So let's find the center point. We can do that by drawing an X. So here's the center point. We drew an X in perspective that found the center point. Now I'm going to draw a line through that center point, and in perspective that goes back to the vanishing point. So draw a line directly through from the vanishing point to the center point. Now if I take a line from this corner of the box and intersect it with this middle point of the box, so let's look at that one more time. This corner through the middle, this corner through the middle. It will stop on this line where the next box would be. So this time there's, we didn't draw the box first, we just drew a line through this point all the way across, and then where that line is, it gives us the endpoint for our new box. And we could do this on and on. So this one was done flat on the ground. Now let's try and repeat an element on its side. So we have that same box. We're not drawing the whole entire box here, we just have it as a flat plane. We're going to draw our X. That gives us a center point. With that center point, we're going to go back to the vanishing point, which goes exactly through the middle of this square. Now we're going to take one of these corners and intersect it through the middle point. A little pro tip that I like to do is we had two options. We could have went from this point or that point and gone through the middle. If we ghost it, so let's ghost from the left to the right, it's a shorter line than if we ghost from the bottom to the top. So that's why I went ahead and I took this line instead of that line, because it's shorter, giving us more accuracy. So where that hits the bottom, we're just going to project it up. And then we could just do that freely now. Corner through the middle, corner through the middle, corner through the middle. And if we give it a certain width, let's call this 50 feet, then if there's 6 of these, we've now established that this is 300 feet. So you could see how architects and planners can really use this to properly represent a space in perspective. Okay, so let's go even more advanced. Let's say we don't want these to touch one another. So back to this example, we have 3 squares lying down. Let's look at this top view. Let's say I want to take one of these squares and push it outwards. How do we do that? Well, we found the middle, created this box, and if I want to space it out exactly 1/2 of this box, I'm going to cut that, and I'm going to take that corner and go through. Project it upwards. We found the middle point, so now instead of having a box that's only 1 cube or 1 square, we have a 1 by a 1.5. Then we duplicate that by going through the middle as we have been. So right there, we're going through the middle. We found our space. We took the corner of our box and we're going through the intersection of our space. And we found where it'll end. So we have 1.5, 1.5. That's a spacer now. Or, apologies, 1.25 on each, 1 1/4. And now we have a box that's exactly half a box away. I keep saying box, I'm sorry. We have a plane. So this is one of those things, like I said, I've slowed it down in the previous video going over the same slides, but right now I want to give you guys the understanding that you can plan things if need be, and you can get it down to an exact science like we talked about. We can repeat these perfectly on our grid. Alright, so one more way to repeat elements. This time, we don't want them touching at all. We want the same rectangle projected somewhere else that we want to plant it in space. We're not going to go super in depth into this, but just understand it exists. We can research it further on if we want to have a better understanding of it. But let's talk about it. So this time, we're going to use a reference point. We drew our arbitrary rectangle. We found it on a 1-point perspective grid. And let's repeat this somewhere else. So on this horizon line, if we crisscross from one corner to the other corner, and we find that point, we now have a reference point for this rectangle. What that means is we can draw these parallel lines which converge to this vanishing point somewhere else on our grid, find the front corner, and now we can use that same reference point to intersect it and repeat this exact rectangle elsewhere. Now maybe let's add one here, go from the point to the reference point, and now we have 3 perfectly mirrored rectangles on this grid at different points where we didn't have to have them touching like we did in the previous examples here. Okay, so repeating elements. Very important, gonna come in very handy. So what else is important to learn with perspective? For me, what I'm gonna say is it's very important to learn about circles. So here's an example sheet from a book called Rapid Viz that you guys can go ahead and screenshot, print this out, and you can create your own box. This is a cube, and we have a circle within the cube. And why this is helpful is if we have this cube and we draw this circle on it, we can start holding it in our hand physically and look and see what happens to this circle from an angle when we're not looking at it at a flat view. So you can hold it, put it on the desk. We can see that that circle gets squished, and we can put it on its side and see how it looks, you know, in that view. So let's talk about circles. Let's talk a little bit about circle anatomy. Here's a circle. What's important to a circle and what makes it a circle is that it fits within a square perfectly. This means that from the center of the circle, if we were to draw a line out, which would be called the radius, that line is the same length from the center point all around the circle. Okay, so back to the example that we used before. If we understand it from a top view, from a side view, we can begin to plan it in perspective. So what sort of techniques and tools can we use to our advantage? Okay, we understood that a square, we can draw an X and find the middle point. Meaning if we draw a square in perspective, we can find the middle point, which is the middle of our circle. What else? Well, a square is perfectly symmetrical up and down. So here is that cut in half. That means that this is mirrored. We can flip it and fold it on itself. The circle also touches the points of the square. Those points where it's folded in half. So right there it intersects, that's where it touches. And then if we were to draw our X, almost exactly 1/3, if we to cut it, is where our circle, the radius is on the X plane. So how can we use that in perspective? Well, here's a square drawn in perspective. We've thrown in our circle. A circle in perspective is called an ellipse. And the ellipse also has its own anatomy. So we talked about the circle, its anatomy, it's perfectly symmetrical, and it's perfectly even from the radius. That's not true with an ellipse. So here, we've drawn in our x, we've now found the middle point. But look what happened. This middle point, going through the circle here, it's further back on an ellipse. It's not at the widest point like we might imagine it to. So although this is the center, the ellipse itself has its own anatomy, which is called the major axis. So the major axis is the center of the ellipse, but it's not the center of your circle. This is very important, and it can lead you to have incorrect drawings if you don't have an understanding. So this center is in the center here, but that's not the major axis. It's not the widest point. Okay, what else? If we draw a line perfectly up and down through the center, that's called our minor axis. So looking at this major axis, this ellipse can be folded on itself on the major axis. Same thing on the minor axis. You can fold it left and right, and it will perfectly fit on itself. Okay, so let's see how else we can use that understanding for drawing. This time let's draw a cube or a square on its side. We find the center of that square by intersecting the points, drawing an X. And that minor axis we just talked about on an ellipse, which is this, it's a tool used to help us draw it. That minor axis also happens to be going to the vanishing point on the horizon line. So let me repeat that. The minor axis of our ellipse goes back in space to the vanishing point on the horizon line. And we'll give some examples of that coming up. So here's the minor axis, and we can fold this ellipse on itself. So here's one more visual representation of a circle. Here is a circle that I went ahead and I printed, and I threw a bunch of these on the floor and I took a picture. So we could see that this ellipse looks larger than the one back here. They get smaller and smaller the further back they go. What that means is that each one of these ellipses is described by a different angle. That angle, the way that we describe them, is our viewpoint of them. So when we see one at 45 degrees from our eye, at a 30 degrees from our eye, 15, and this is done from our eye level. So 45, 30, 15. If an ellipse or a circle is on the horizon line, it would be 0. It would be a flat line. So the bigger or the closer it is to you, then the bigger your ellipse is going to be. Okay, so that's a quick understanding of circles, ellipses. We'll show you how to draw some cylinders with that. Now let's talk we're going to go over the rest of these quick. We only have 2 more talking points that I really want to discuss. 3 more, sorry. But once again, we're going to brush on it. How can we use these besides the literal way of drawing circles on our grid? Well, we can be smart and we can understand that if we want to open up a door, that door right here, the width of the door, we can think of it as a radius on a circle. This is the center point where it pivots from, and this door will travel in a circular method. If we see it from a top down, if we draw a radius, it forms a perfect circle. That's why it's very important, once again, to be able to draw ellipses in perspective. So let's draw in our vanishing point. We're going to take the width of this door. I created the box. We're going to duplicate that. We've now found that same width over here using our repeating method. And this is now the widest point of our ellipse. Or I'm sorry, this is the center point of our ellipse, not the widest. Okay. And I corrected myself there because the widest point is the major axis. This isn't the major axis, it's the center. So now we found the width, we found the center point, we found where that circle would intersect over here. You could see this is the widest point of our ellipse, but this is the center point. If it travels on a circular path, we can now go ahead and open up this door, and we'll have a door that actually looks like it's going to close, because if we didn't have this guide, we wouldn't understand where to stop this line. We could stop it here, we could stop it here, and it may not look like it's closing properly. So because items on a hinge travel in a circular path, we could use this to our advantage. All right, what else do I want to brush on real quick? So here's that same door. We traveled a little bit further on that circular path, and now we've opened it wide. Still looks like it should close. All right, let's briefly talk about inclined planes. Once again, we can go much more in depth into this later, or you can reference the other references I was talking about, the videos and the books. But this is now, how do we find where an inclined plane would be in perspective? So the way that we could do that is by drawing in a road. Let's find where we want to begin to draw an inclined plane, and we're going to create this vertical vanishing point. That's a new term for you, vertical vanishing point. So a vertical vanishing point is a reference point that anytime we want to draw something on this inclined plane, we just trace back to that. So we establish one side, we find this point straight up from our vanishing point, and then that can be a reference for the other side of our inclined plane. We can draw it further back into perspective now, and we can go back up. So these planes, they're at the same inclined angle. Let's do it now with a box. So here's a box, drew in 2-point perspective. Let's zoom out. I've created this reference point, this vertical vanishing point. Let's find the middle of this box using our X method right there. And let's pretend I want a house, and this is the roof of the house. We're going to intersect through that, come across it, draw through our box, go once again through the middle, and now we have points that we can connect. So that is if the front of the house is at an inclined plane. Well, if we want to mirror that, instead of having to find a new vertical vanishing point, we can go back into perspective right at this point. Because we know this is symmetrical, we can simply draw an angle of where that house, that roof, were to fall. So these are shortcuts that can help us draw things that are symmetrical. And we're going to use that if we have the knowledge, we're going to use it all the time in our drawing in order to properly represent elements in perspective. So the very last thing that I want to talk about right now before we get into the demo is the cone of vision. This is more of an advanced concept, and the reason I call it an advanced concept is because often you see beginners, they learn 1 point, they learn 2 point, they learn 3 point, and they start drawing, but things start looking weird. They start getting weird angles in their boxes, and they draw them too skewed, and it looks wrong. And you may notice this with your drawings or other students' drawings or a friend's drawings, that it looks wrong and you can't tell why. This is because every lens, such as our eyeball is a lens, a camera has a lens, it has a specific field that it can capture, a specific cone, an angle. And as humans, we have roughly a 60-degree cone. So this is that station point we talked about earlier. Where the camera is, where our eyeball is, this is us. If we draw a 60-degree cone out of here, this is how we see this box in perspective. Now if we get closer, all of a sudden that box gets larger. So we traveled closer, it got larger. The same thing happens if we go back. It gets smaller. And what this allows us to do is the cone begins to help us establish how far can we draw within our drawing plane while still having it look correct. Okay, so let's see that. This is us, the center of vision. We drew in a 60-degree cone. This cone gives us 2 points, 1 and 2. And if we happen to draw a circle from those 2 points, so we take the middle, that's the radius, and we draw a circle, this circle now is our cone of vision. This is what we can see without distortion occurring. If we wanted to draw something fisheye, we can begin to obscure the cone. So different lenses have different cones. You can go tighter, you can have a 30-degree cone, you can have a 90-degree cone. So this is a 60, a human eye. So this is a 1-point perspective. And in 1 point, we have just 1 point and our horizontals are perfectly horizontal. So let's go ahead and turn that now. Let's try to establish another grid in our cone of vision. 2 point. So these points, they're 90 degrees away from our center of vision. This is a 90-degree angle. That lets us establish 1 point. Our second point is way off the page. But now we can create our grid, and once again, if we draw within this cone of vision, we're safe. So let's rotate this even more. Now we've rotated it to where the vanishing point is actually in line with our cone of vision. That means this point, once again, it's off page. We can use a bigger sheet and create our grid. And then this time, we have the vanishing points on the page. So right here's one vanishing point, right here's the other, and we're drawing in our lines. So let's look at these one more time. This is a 1-point grid. This is a 2-point grid with vanishing points at these angles. And we keep rotating this 90 degrees from our center point. 1, 2, 3. But the cone never changed. It always stayed within this circle, this 60 degrees from our center point. And now we can go ahead and we can create frames. So we can create a frame using this grid. We can create a smaller frame using this one, and we can zoom into it, or a larger one. As long as we draw this frame within this cone of vision, there should be no distortion. So, like I said, there's some basic, intermediate, and advanced concepts. They're all stuff that I want you guys to be aware about when you're doing your drawings. But now let's go ahead, let's go back to the basic understanding that we had, and let's use some of these principles for the demo.